pre-calcers. So today we're going to talk about parametric equations. So for the most part, for all of our kind of mathematical approaches, we've been talking about rectangular equations where it's just two variables. Most of the time, those two variables are x and y. All right, so rectangular equations contain two variables. Usually it's x and y. All right, so let me just get rid of those little random marks that came up. When we talk about parametric equations, it's going to contain another, and it's called a parameter, which is another variable, which is called a parameter. And that's so that we can measure different things. So like kind of real world application to kind of talk about it. Say you are, now here we go with my drawing. You guys know how absolutely awesome I am at drawing. Say I am taking foul shots. All right, here's my, that's my hoop. Terrible hoop. All right, and I have my basketball and I'm going to shoot my basketball. Okay. Wow, that was terrible drawing. All right, so anyway, moving along. So when you go to shoot your basketball, you can talk about where the basketball is in two different things. You can talk about the height of the basketball in your shot, and you can also talk about how far away is it from the actual hoop. Okay, so we can talk about like the vertical height, and we can talk about the horizontal distance to the hoop. So those are like two things, and we can say, oh, okay, you know, after 1 second of leaving my hand, the ball is here. Okay, so after 3 seconds, the ball is here. I don't know why the ball just got bigger. It doesn't even look like it's going to fit in the hoop. So after that, like, so we use a parameter. And in this case, where I'm saying like 1 second or 2 seconds, we would say my parameter is t. T equals 1 second, t equals 3 seconds. We said it was like there. All right. So parametric equations contain a parameter. Another variable, aka a parameter, where x and y, like how we talk about this, x is my horizontal distance and y is my vertical distance. Okay, so y would be my height, x would be my distance to the basket, where x and y are defined. All right, so we've got parametric equations contain another variable, which is also known as a parameter, where x and y are defined by that parameter. So if we kind of look ahead at example 1, we've got find each point based on the parametric equations. Let me just get rid of my basketball drawing. I know you guys are dazzled by my artistic abilities, but just in case I need the space to do this, there we go. All right, so for this next one, we've got find each point based on the parametric equation. So we've got x, which is defined as t, and then we've got y, which is defined as t, and then it tells us that t is equal to 1. So we want to find the point, we want to find the x comma y. So what I'm going to do is I'm just going to take t and plug it into the x one. So x equals 4 times what my t is, which is 1, plus 3. So my x is 7. And then my y is 2 minus my t, which is 1. So y is equal to 1. So my point is 7, comma 1. And it's that simple. All right, for the next one, we've got same idea. We want to find that point, and it's a little bit more complicated of equations, but it's the same thing. We're still looking for that x comma y, and we're given that x is 2t minus 5 and y is t squared plus 4, where t is equal to negative 3. So we do x is equal to 2 times my t value, which is negative 3 plus 5. Oops, sorry, minus 5. So we've got negative 6 minus 5. So we've got x is equal to negative 11. And then we've got y is equal to t squared. So in this case, my t is negative 3 squared plus 4. So we've got 9 plus 4. So my y is equal to 13. So the point is going to be negative 11, comma 13. All right, so that's my x and y coordinate. So now, guys, if you think about it, actually, another place where we have seen a parameter where my x and y are defined by a different thing, and based on what your parameter is, it's going to be a different location. Your unit circle. Yeah, because whatever your theta is where your x and y is going to be, right? Because we defined x as cosine theta and we defined y as sine theta. So actually we have dealt with a parametric equation. We just, didn't know that it was labeled as that. All right, on to the next one. So we've got sketch the curve described by the parametric equation. So now we're going to do the same exact thing, except for this time we have a couple different t values. So we're going to just roll through this chart. And the only other thing that we're going to be doing, other than plotting the x comma y, we're going to indicate the direction of the curve, which is also known as the orientation. So I'll show you guys when we go ahead and graph that, just how we would do that. All right, so first thing, t is negative 2. So my x is going to be negative 2 squared minus 4. So that's 4 minus 4. So that's 0. And then my y is negative 2 over 2. So that is negative 1. All right, so my next one, x is equal to negative 1 squared minus 4. That equals 1 minus 4, which is negative 3. And then my y is negative 1 over 2, so negative 1/2. All right, my next one, we've got x is equal to 0 squared minus 4. So we've got 0 minus 4. So that's negative 4, comma, plugging in y is equal to 0 over 2, so 0. And then I go ahead with my next one, x equals 1 squared minus 4. So that's 1 minus 4, that's negative 3, comma, y is equal to 1 over 2, so 1/2. And then we've got 2, my last point, my t value is 2, x equals 2 squared minus 4, so that's 4 minus 4 is 0. And then y equals 2 over 2, so 1. All right, so now I'm going to go ahead and plot those points. So I go to my x's and y's. So 0, comma, negative 1 is my first point. So sometimes we can label that as my initial point because I was given that as my graph. So I could label that as my initial point. All right, my next point is negative 3, comma, negative 1/2. Okay, negative 3, comma, negative 1/2 is right there. Then my next one is negative 4, comma, 0. And then my next one is negative 3, comma, positive 1/2, so right there. And then my final point, aka we also could call it a terminal point, which is meaning where it ends, is right at 0, 1. All right, so that is my terminal point, TP. All right, so now to show the orientation, all right, like we set up here, indicate the direction of the curve or the orientation. Well, I start at my initial point and then I went like this, right? So in order to show, I'm going to just do them in a different color so you guys can really see how you would do it. I started with the initial point and then I went like this. Okay, I do little arrows just to indicate the direction. You can do them in the same color. I'm just showing you in red. So it starts at my initial point and then it goes whoop, so you can just see, because after you take your, once you connect the dots, you don't know what way you drew it. So we're going to indicate the orientation with little arrows. Okay, so that's how we indicate the direction of the curve, what way we sketched it. All right, on to the next one. So we're going to do the same exact thing. Oh, by the way, guys, we know what that is. We've seen that before. That's a parabola, right? Sideways parabola. It opens to the right, so it should be a y being squared, and it should be a positive one because it opens to the right. I'm going to come back to that. That's why I said that. All right, on to the next one. So we're going to do the same exact thing. We're just finding x's and y's. So plugging in -2. So whoa, I keep zooming in. I don't know what's going on today. Sorry, guys. So we've got x equals 3 minus 2 times -2. So we got 3 plus 4, so x is 7. And then y is 2 plus 3 times -2. So 2 plus -6, so that's -4. And then my next one is x equals 3 minus 2 times -1. So that's 3 plus 2. So we got 5. And then y is equal to 2 plus 3 times -1. So 2 plus a -3 is -1. Then we've got x equals, when it's 0, t is 0, x is 3, and y is 2. So 3, 2. All right. X equals 3 minus 2 times 1. So 3 minus 2. My x is 1. My y is 2 plus 3 times 1. So 2 plus 3, 5. And then my next and final point that I have to find is x equals 3 minus 2 times 2. So we've got 3 minus 4 is -1. And then my y is equal to 2 plus 3 times 2. So we've got 2 plus 6, 8. All right, so we're going to go ahead and plot those points. So my initial point is 7, -4. So I'm going to label that as IP. That's my initial point. And then I go to 5, -1. And then I go to 3, 2. And then I go to 1, 5. And then I go to -1, 8. And that is my terminal point, TP. Oh, wow. So these all kind of line up. And I start at my initial point. Let's see if I can hit these. Woo! Pretty, all right, not too bad. All right, now to do the indicated direction of the curve, the orientation, I started here and I went that way. Okay, so this is a linear equation, and we'll come back to that in a second. All right, guys, you try part 1 right now.